So we can see here what wedge looks like. And wedge is a triangular shaped piece. It is a simple machine that is used to raise heavy loads. And wedges is considered as one of the simple machines together with the lever, wheel and axle, pulley, and screw. Basically, wedge is an inclined plane, and it is a device that tapers to a thin edge, usually made of metal or a wood, and the wedge can have one or two sloping slides. So here, the wedges is an object that is used to split something open, like you put a wedge in a log, for example, or to split the log, or you could put a wedge in some things to lift an object. So wedge under friction is used for the separation of two bodies, to support or hold a body and to lift a body. So, for example, in this figure, figure A, these are the two bodies, the body 1 and the body 2. If I will insert a weight in between them by applying a force, body 1 and body 2 will be separated. In figure B, we can see that the body here is in inclined position due to the weight that is inserted at its bottom. To keep this weight in position, there has two conditions. It is to continuously apply a force, or if the friction are such that the wedge can be rearranged so that the position remains and no need to add additional force. In this figure, the friction prevents the wedges from sliding out. In this figure, figure C, in order to lift the body, the wedge is inserted at the bottom in order for the body to be lifted. When the wedge is in the operating condition, friction governs a very special role to operate the wedges. So wedges is used to separate two bodies, support or hold a body, or to lift a body. So in here, what is happening in here is that we drive using a force the wedge in between the object A and object B. Object A will go upward and we have an upward motion. So the question is, how much force is needed in order to lift up object A? So here is the free body diagram, object A itself. Object A has a weight here that is equal to the mass multiplied by the gravity, and the normal force here that is to balance on the bottom surface. We also have a friction force here as we're driving the wedge in here to push object A in the surface at C. So the friction force will be between A and C, and as you are trying to push the object A upward, then it will be a friction force pushing downward, which means the upward normal force at the bottom of object A counterbalance the friction force at surface C. We can also see that the force that is driving the force in here will cause the friction force to exist between object A and object B, which cause the force to act on object A in the positive x direction. Thus, friction force at A, which is the normal force at A multiplied to mu, double than the normal force here at C, which causes the friction force in here. The greater this friction force, the greater the normal force, the greater the friction force there. Notice that the friction force at A is equal to the normal force at C. Eventually or finally, you can say that if normal force at A is larger enough to overcome both the weight of an object A and the friction force at C, or if the normal force at A is greater than to the weight plus the friction force at C, then we can conclude that the object will go upward.
So I'm here to discuss about the problem number 1 of wedges under friction. So the block A in this figure supports a load of 50 kilonewton, and this block will be carried by the block under it, which is block B. The angle of friction for all surfaces is 18 degrees. Determine the force F, which is necessary to start the wedge under the block. So first thing we will do is to analyze first the figure. So as you can see, force F here is going to the left towards block B. Excuse me. So kung lantawan mo, ang force nga ni makato sa block B, which pushes the block and will make the block B go padalom. So una-una, drawing unta ang block A. So drawing unta dako para klaro. $50 kilonewton. Block A. So, as you can see, ang force nga gina-apply sa block A, which is its weight is going downward. So we need to resist that. So duwa ang makaresist ang amuna. The surface of A and B and the surface of this wall and A. So first thing to draw is ang drawing unta ang surface ng A kag ang wall nga ni. So una-una drawing unta ang friction niya F1. So this is our normal force 1. And naka-state nga ang angle of friction for all surfaces is 18 degrees. So this will be RR1, reaction 1, 18 degrees. 18 degrees na. Tapos, drawing on to next is ang surface of A between B. So, aray sa ang F2, friction 2. Tapos, pakatod di ang normal force 2. Tapos, may 18 degrees din nga R2. R2 tana. So, may tatlo na taka. Ang 18 degrees nisa. 18. Basta 18 degrees. So, may tatlo na taka force. R1 and R2. So, if you need gusto tabalan nun ang mga angle nila with respect to x-axis. So, we need to draw this a line here. So, this is 30 degrees. As mentioned, 30 degrees. Madrawing to the y-axis. Ang are 30 degrees na. 30 degrees. Then, if this is 18 degrees, 18 degrees, sa 18 degrees na sa, this is 30 minus 18, 12. 12 degrees. Tapos, kung gusto ko ako ng angle sa R2, so, 90 degrees minus 12 is equals to 78. So, 78 degrees ang R2. That's the end of our part 1.
So good day everyone, I am Ronald Calabio and I will discuss to you the continuation with regards to the problem about wedges. So after you make a diagram of block A with different forces and angle, wherein you've got your force 1, force 2, normal force 1, normal force 2, the R1, R2, and the different angles. Now is the time that you can make your force triangle. So for first, you have to put the 50 kN, which is the weight force here. Next is, which is located here. Next is the R2, which is located here, wherein with respect to its to the x-axis, which has 78 degrees, therefore you have 12 degrees here. And next is the R1, which is located here, with respect to the horizontal axis, which has 18 degrees, so you have 72 degrees. So in order for you to get the third angle inside the triangle, you have to subtract 72 and 12 degrees by 180 degrees. So 180 degrees minus 72 plus 12. So you have 96 degrees as your third angle. So after you complete the angles, you can now solve for its R1 and R2 by using the law of sine. So R1 over the opposite angle, which is 12, so you have to put sine 12 here. And next is the R2, which has 72 degrees here, so therefore you have to put 72 here. And next is the 50 kN, and you can have your 96 degrees here. So in order for us to know or to find the R1, you can directly input the values in the calculator and use shift solve if you want, but you can also use the way or process wherein you can cross multiply. So 50 kN over sine 96 times sine 12. So 50 over sine 96 times sine 12, and we have 10.45. 10.45 as our R1, and then R2 50 kN over sine 96 multiplied by sine 72 equals to, So 50 over sine 96 multiplied by sine 72, and therefore we have 47.81. So here it is, we have our R1, R2, and the weight force itself. So thank you.
Hello everyone, and I am Mark Genevie Bolongaita, and I'll be continuing the problem 1 regards to wedges. Here we will be solving for block B, since we have already finished block A, but we'll still be referring to the drawing right here. Here we have the drawing block B with force going to the left, and since we'll have an equal force, friction force over here, going the opposite side, and here we'll be plotting the normal force, as you can see, N3 with 18 degrees for R3. So we have here a lot with the first illustration. This is R3, and we'll be copying it as well. We know that R2 is 12 degrees as here. It's simply the opposite side here, so we'll know that it is 12 degrees with respect to y. So this here, R2, is 12 degrees with respect to y. So we also know that 90 minus 12 equals 78, so we'll know that R2 is also 78 degrees with respect to x here. This is a flat line which will represent x. Here we'll be drawing our force triangle. As you can see, we have F here on this side, and since we'll be drawing R3, and we know that it is 18 degrees with respect to the normal force, which is a straight line downwards. So this is 18 degrees, this one, and we'll be drawing R2 here as well. R2 would be on this side. We know that it is 12 degrees with respect to y. So here, this is 12 right here. That's not really clear, but we'll go along with it. Here we have 78, since we know that R2 is 78 degrees with respect to x. So here we have 78 degrees. So 78 degrees, we'll use that. Since this is a whole 180 degrees right here, we'll be doing 180 minus 78, so we'll have 102 degrees for the inside angle here. And since we'll try to find the inside angle here as well, that would be 18 minus 12, we'll have 6. So here we'll be able to solve using the sine law. So using here, we'll use F with sine over 6. So F over sine over 6 equals, we'll be using the previous ones we solved, which is R2 right here. R2, we know the exact number or value of R2. So R2, which is 47,815, which is with sine 72. We know 72 degrees here. So we'll have F equals 47.815 over sine 72 times sine 6, and we'll be having 5.255 kilonewtons. So here we have F already, but we'll still be solving for R2. So R2 right here, R2, oh no, this is R3. R3 over sine 102. It's right here, since it's opposites to each other, equals, since we already used R2 for our first value, we know both values, the values for R2 and its angle, so we'll use 47.815 over sine 72 right here, sine 72. So we'll have the solution R3 equals 47.815 over sine 72 times sine 102. And we'll be having R3 equals 49.177 kilonewtons. So here we have all the values. We have F, R3, R2, and R1. And that would be all for the problem regarding wedges. With the problem number 1, we'll be proceeding with the next reporters. Thank you.
Good day everyone, I am Sidrick Nuel Palacios from group number 1, and here is our problem number 2 about wedges. Determine the weight of the block A so that the system of blocks will move to the right as shown in this figure. So block B weighs 15 kilonewton and the angle of friction is 15 degrees. So the weight of this block is 15 kilonewton and the weight of this block is unknown. So we need to find the weight of this block. So sa block B, may kita weight, sa block A wala. So if we go to block A, there are 3 unknown factors. These are the weight of this block, the reaction between the surface of block A, and the reaction between block A and block B. So dapat sa block B kita first makadto. Okay, there are only 2 unknown factors. The reaction between block B and the surface, and the reaction between block A and the block B and block A. So here is our block B. Wait lang, I don't want to sa. So block B, and ginambal diri nga it weighs 15 kilonewton. 15 kilonewton. So since ang movement is going to the right, meaning kailangan to na siya i-resist. So here is our frictional force number 1 going to the left opposite para ma-resist ang imo nga imo nga movement. So here is frictional force number 1, and here is our frictional force our normal force number 1, which has 15 degree angle, and this is your reaction force number 1. So kung diri naman da sa A and B, we remember our movement is going to the right. Ang matabo da is ang atong block A will go downward in order to push the block B to the right. So meaning our frictional force between A and B is upward. So pagkadto ta sa block B, mahimo na siya nga downward. So amo ni ang iyang matabo. Here is our frictional force number 2, and here is our normal force number 2 nay para parallelogram sa. So ang at normal force number 2 may 15 degree, ang angle of friction is 15 degrees. So here is our reaction force number 2. So the next part of reaction force number 2. So the next part of this problem will be discussed by my other group mates, which they will tackle about how to solve and to find the block A, the weight of block A. Thank you.
Applying the triangle law, we can summarize this by writing the weight, which is 15 kilonewton 15 kilonewton, and then mirror the reaction that we did here. So let's go with R2 first. So R2 is going in this direction, R2, and then the R1 here, which is going upward. Applying the head to tail fashion. So this is R3, R1, and then we will also write the degrees, which are 15. So the degree here is 15 degrees, another 15 degrees here, and here 15 degrees. Next is we're gonna find the angle here. So to find the angle, we can minus the 15 to 90 degrees, since this is a right triangle. So 90 minus 15 degrees is equal to 75 degrees. And then we're also gonna find the angle here between this angle, and to find that we're gonna minus 75 degrees to 15. So 75 minus 15 is equal to 60 degrees. And then since to get the angle here, we will plus 60 plus 15 plus 15 degrees, and that is equal to 90 degrees. And then the total of this, the angle here is 90 plus 15 is equal to 105 degrees. Applying the sine law, we can have an equation of R1 over sine 105 equal to R2 over sine 15 degrees, and equal to 15 degrees over 60 degrees. And so solving this, we can have an answer of R1 is equal to 16.73 kilonewton, and R2 is equal to 4.48 kilonewton. Since we now have the R2, we can now solve for block A. Block A. Then we will copy again the figure. Block A, the unknown weight, we'll just call it W2 or WA, and then applying the friction and the force that we did here, it will be here the N2, and then F2 and the reaction. (15 degrees at 15 degrees). So now we know the value of R2, which we solved a while ago, is equal to 4.48 kilonewton. 4.48 kilonewton. Since block A is going downward, the friction of block A from the surface here is going upward sideways here. We will call this as F3, and then a force here and we will call it N3 with the reaction R3, which is again equal to 15 degrees. And as you can see here, there is a 75. That is the inclined plane degree. So 75 degrees. So applying the 75 degree here, we can make it like this. So the degree here is 75 degrees, and the angle here from R3 to this one is 60 degrees. 75 minus 15, 60.
Hi guys, so my name is Yu, and I'll continue what my classmate has left from problem number 2. So from block A, we will make a forced triangle. So this is the weighted A or WA, and this is the R3. So after R3, as you can see here guys, we have a 60 degrees in y-axis. Here 60 degrees in y-axis. 60 degrees in y-axis. So we will also put the R2 that is 4.482 kilonewton. And here guys is a horizontal line, and the angle is 15 degrees. So 90 minus 15 is 75 degrees. So 75 plus 60 is 135 guys. So 180 minus 135 is 45 degrees angle. So we'll make so our WA over sine 45 equals to R2 na 4.482 kilonewton over sine natin na 60. Sine 60. So WA is equals to 4.482 over sine 60 times sine 45. So our WA is, so ang WA natin or ang weight for the block A is 3.660 kilonewton. So this is our final answer for the problem number 2. Thank you guys.
This is our third example problems about wedges. The problem states that what force P must be applied to the wedges shown in the figure to start the block system. Angle of friction is 10 degrees for all contacts. So we have here a angle of 10 degrees and we will start it at block A. So I've drawn here the FBD of block A. So this is block A. We have a force P here. So the force P is the direction of force P is to the right, so we will have to resist it having a frictional force right here. So this will be our F sub 1, and our normal force right here will be R N1. So as we have F1 and N1, we will have a resultant here will be R sub 1 with 10 degrees. So since we have our F1, N1, and R1, we will have here our F2 to the left. Will be R F sub 2 with our normal force here, and to end our resultant will be R sub 2 also with 10 degrees. So since this inclined plane has a angle of 30 degrees right here, 30 degrees, so as I will draw here a vertical line and a horizontal line here, we can have a 30 degrees with here. This angle will be 30 degrees. So if this is 30 degrees, this angle, this whole angle would be this will be 60 degrees. So if this is 60 degrees, this angle will be, so 60 minus 10 degrees will be 50 degrees.
So, good morning classmates. Previously, the given values of the angles were already identified. So, now, the next thing we will do is that we will use the triangle law in order to determine what equation we're going to use in order to get the value of P. So, based from the figure above, the direction of P is to the right. Next is R1, and its direction is to the right, is upward to the left, Next is R2, its direction is downward to the left. So again, this is P, R1, and R2. Next is, to locate the angle here, based on the figure above, this will be 50 degrees. Next, R1 intercept to y-axis, so this will be 10. 10, and this angle here will be 40, because if we cut the triangle into half, we will form a right triangle. And we all know that inside our right triangle is equal to 90 degrees. So 90 minus 50 is equal to 40. Next, in order to get the angle here, we need to sum up all the angle from here and here. So 50 plus 50 is equal to 100. And 180 minus 100 will be 80. So this angle will be 80. So the next thing we will do is that we will use the sine law in order to get an equation that will help us to determine the value of P. So we will use this side and this side. So P over sine of 50 degree is equal to R2 over sine of 80 degree. So P is equal to R2 sine of 50 degrees all over sine of 80 degrees. So P will be 0.7779 R2, and R2 is equal to 1.286 P. So this again, this will be our equation number 1. So again guys, may correction gali. Hindi andi sa R, muna siya pinadi siya. Sorry. So again, this will be our equation number 1.
Good day, my name is Francis Amado D, and I will continue the solving problem number 3 under the subtopic friction of wedges. So in problem number 3, what force P must be applied to the wedges shown in figure 43.0 to start the block system, which is the angle of friction is 10 degrees for all contacts. So after solving for block A, this block, we will now get the P using the triangular force of solving, and we get the value of P, which is 0.779 R2. This is the equation 1. So for block B, and I will do it in another paper. So for block B, I will draw at block B. So I'm drawing this block for reference. So this weighs for 50 kilonewton. Now, the next step is to get the frictional force of block B. We will now get the normal force and the friction force of block B. The friction of block B will be this. I'll draw here. This is F2, and this will be the normal force because the block is usually like this in our problem. So this is normal force. And now the force R2, to get the R2, so it is located at 50 degrees, or the resultant is at 50 degrees. 50 degrees. So this will be the resultant, R2. Same on the other side. I will just copy here. friction force and the normal force. My drawing would not be accurate as possible, but this is how I get the resultant. So as I said, it's the same, located at 50 degrees. Resultant will be here. And now we will solve, we will now equate the force triangle. So 50 kilonewton, R2 here, and the other R2 here. The angle on the horizontal will be 50 degrees on both sides, and the angle here is 40, same on the other side, 40. And now to complete the triangle, it's 40 plus 40 is 80, so this will be 100 degrees. So for solving the triangle, R2 over sine 40 degrees is equal to the weight 50 kilonewton of sine. The opposite angle is the opposite is sine 100 degrees. So R2 is equals to 50 over sine 100 degrees times sine 40, and R2 will be the R2 is 32.635 kilonewton. So now that we get the R2, we will now input here the value of R2 in P from equation 1. So from equation 1, P is equals to 0.7779 times the R2, which is 32.635 the P is 25.387 kilonewton. So after solving, this is now the required force for the block to move in this problem. The value is 25.387 kilonewton. That is the required force in order for the block to move.